Bismillahirrahmanirrahim. Hello and welcome to Dr. Saqib Khan Science Academy. Today we will learn about Elovich adsorption model. The Elovich adsorption model, the basic assumption is to understand the chemisorption nature of the adsorption. So Elovich adsorption model is applied. We want to understand the chemosorption nature of the adsorption. And this model helps to predict the mass and surface diffusion. We can say that Elovich model is used to describe chemical adsorption and is applicable for heterogeneous surfaces. If we want to study the heterogeneous surfaces, then this model is applied. The equation for Elovich adsorption model, the linear form of this equation is Qt is equal to 1 over beta ln alpha beta plus 1 over beta ln t. This is simple linear equation y is equal to mx plus c, in which alpha is primary rate of adsorption while beta is desorption constant during each experiment. So from this equation we will calculate the value of alpha and beta. Our slope will be 1 over beta while our intercept is 1 over beta ln alpha beta. This will be our intercept. The x value ln t shall be plotted against qt value. Qt is adsorption capacity at time. I have calculated the adsorption capacity at time in my previous videos where I calculated the PFO model. In PFO model, I calculated QT and QE. The formula for calculating QT is equal to C naught minus CT multiplied by volume divided by mass or W. So this is our QT value. You can go to my previous video which I made on pseudo first order kinetic model and I have explained this in detail. Over here I will just put the formula to calculate QT. So we run the experiment for 10 to 120 minutes. Our initial concentration was 30 milligram per liter or 30 ppm, while we calculated the CT value at different time intervals from 10 to 120 minutes with 10 minutes interval each. According to formula, our x-axis will be ln t. So we will calculate ln t first and then we will calculate the y value, qt value. So for calculating ln t, we will take ln of the time value, ln of this. So this is our ln t value. Now we will calculate. Now we will put the formula for qt is equal to initial concentration minus final concentration multiplied by volume divided by mass. As in our case, I already told that our mass and volume was same. So we can just put multiplied it with 1 or we can just only do C naught minus CT. That will give us QT value. So this is our QT value. In the formula, this B11, these values shall be used throughout the formula. So we will log these values by putting $sign before and after. And then double click this one, the formula will be copied. So over here, we will plot ln t versus qt. Go to the insert. In the charts, select the scattered one. And this is our now we will make a trend line, linear trend line of this and display the equation and R square value. Because from this equation we will calculate the slope and intercept. So our slope over here is 6.5976 while our intercept is minus 14.347. So according to the formula, our slope is equal to 1 over beta, while beta will be equal to 1 over slope. So this will be equal to 1 divided by the slope value. Okay. Now, from the intercept, we know that from the equation, we know that intercept is equal to 1 over beta ln alpha beta, or intercept is equal to 1 over beta ln alpha beta. If this beta value comes over here with the intercept, so this will be equal to intercept into beta is equal to ln alpha beta. Then this equation, we can manipulate this equation, and intercept into beta will be equal to ln alpha plus ln beta. As we already have beta value, so it will be equal to ln alpha plus ln beta. And then our ln alpha will be equal to intercept into beta minus ln beta. So our first we will calculate the ln beta value. Our ln beta will be equal to ln of beta value, while our intercept multiplied by beta, our intercept multiplied by beta value will be equal to, we will multiply intercept into beta. So this will be equal to intercept multiplied by the value of beta. So this is ln alpha, this is intercept into beta, while our ln alpha is equal to intercept into beta. This will be equal to intercept into beta minus ln beta. So this is the value of ln alpha. Our alpha will be equal to exponent of the ln alpha value. This will give you the alpha value. So our alpha value is 0.749. Alpha value is 0.749, while our beta value is 0.15. As I told you that alpha is the rate, alpha is the initial rate or primary rate of adsorption according to Elovich model, while our beta value is the desorption constant. So from here, we calculated the primary rate of adsorption, and while our R square value is 0.9367. So our R square value is 0.9367. We use the data which we already applied for Langmuir adsorption model, for Friendlich, for DR and Thumbkin isotherm model. So the same data we have used over here for Langmuir model, Friendlich model, DR model and Thumbkin model. You can see my previous videos. I'll give the link in the description. This is all about Elovich adsorption model. Hopefully now you understand how to fit your data in Elovich adsorption model. If you got some information from here, please like the video, subscribe to my channel and share this video with other colleagues. Your like and subscription will motivate me to create more informative videos like this. Thank you very much and Allah Hafiz. Bismillahirrahmanirrahim. Welcome to Dr. Saqib Khan Science Academy. Today we will discuss about intraparticle diffusion. Before this, we discuss about pseudo first order, pseudo second order and first order reaction. As you know that the adsorption is a surface phenomenon. This means that the particles or the molecules that are adsorbed on the surface of the adsorbent. But you know that whenever there is some adsorbent, it may have intracellular spaces, and the particles may diffuse inside those intracellular spaces and can adsorb over there. In this figure, you can see that the intraparticle diffusion is a bit explained. The adsorbent molecules, the adsorbate, they you can see that intraparticle spaces inside an adsorbent, and these the adsorbate molecules, they can enter inside and they can adsorb onto the active sites. So this model explains the basically the process of diffusion. The equation for this model is Qt is equal to KID plus T half or T underscore plus I. This is I. I is basically the thickness of the layer, and K is the intraparticle diffusion constant. This model is also called as Weber-Morris model or IPD, intraparticle diffusion, IPD model. Okay, let's write IPD. IPD model. Okay, so if you linearize this equation, y is equal to mx plus c, or y will be qt, and m will be the k value will be our slope, and x is on x-axis we will take t underscore or t half, and I will be the intercept will be our thickness. Okay, first of all, let's calculate qt. Qt, the formula is C naught minus Ct divided by mass of the adsorbent multiplied by volume. So in this case, our volume reaction volume in liter was 0.01, 0.01, and mass of the adsorbent in grams was also 0.01. This means that 1 milligram per ml or 1 gram per liter. So this is equal to C naught initial concentration minus Ct multiplied by volume divided by mass. This we will log the column by putting the dollar sign before and after the column number. Before and after the column. And we will drag it till the end. For t half will be equal to square root of our time. Square root of time will give us the t half. Okay, now we will make a graph between t half and qt. We will plot this t half and qt. Let's edit this. Our x-axis value is t half, while our y-axis value is qt. Give this name as intra, or you can simply write it IPD model. So we will add a trend line. We will add a linear trend line and display equation and R square value, which will give us the value of intercept and slope. Our slope is the k value 1.826, and our intercept is minus 2.06. As our intercept value or the thickness value is in minus, so this means that the R square value is 0.96. 0.96. Okay. As our intercept value is in minus 2.06, this means that multiple there are different factors which are affecting the process. So the intercept can be negative. The negative intercept can be explained by the combined effect of film diffusion and surface reaction control. So in 2008, Langmuir in his paper, he said that it can be explained by the combined effect. So this means that if your intercept value is negative, there is combined effect on the system. So it can be negative. Mostly in most of the cases, this is zero or positive. It is passing through, the intercept is zero or it can be positive. But if you are getting the negative value, this means that the system is controlled by the combined effect of film diffusion and surface reaction. So there is surface reaction, surface adsorption is also taking place, surface reaction is also taking place, and there is also the phenomena of film diffusion. Film diffusion I will explain in next lecture, but over here you just understand that the negative intercept value, it can be, you can get the negative intercept value, and it can be explained by the combined effect of film diffusion process and the reactions which are taking place on the surface of the adsorbent. So let's play with these, and you can now add the chart elements, axis title, x-axis, and y-axis title. Our y-axis is qt, milligram per gram, while on our x-axis is t 0.5 in second or half second, t half. So now this is our IPD model. Hopefully you understand how to plot the data in IPD model and interpret the data. If you obtained negative intercept, then how you can explain that can be the combined effect of different systems. It can be due to film diffusion process and the interaction between the film diffusion process and the surface reaction. If you find these explanation helpful, please like the video and share the video with your fellow students and colleagues. Thank you very much, and Allah Hafiz. Bismillahir Rahmanir Rahim. Hello and welcome to Dr. Saqib Khan Science Academy. Today we will learn about fitting the data into Langmuir adsorption isotherm. This is a series of lecture in which we will discuss about, we will fit the data into different adsorption isotherms. Our next lecture will be about data fitting in Freundlich isotherm. Then the other adsorption models like Hasley, DR, Thumbkin, and Fromkin, all the isotherms we will discuss in this lecture series. So let's start our lecture about fitting data into Langmuir adsorption isotherm. Before going into the details how to fit the data, if you have any problem in adsorption modeling or photocatalytic modeling, then you can comment in the comment section. So we have this model data from our experiment. We did experiment on different initial concentrations from 10 up to 100. We did our experiment for all the concentration and we measure the concentration at equilibrium. Our equilibrium time was 60 minutes. So after 60 minutes, the concentration of equilibrium we find out for different concentration. Before fitting the data, you should know that the Langmuir adsorption isotherm, the equation of Langmuir adsorption isotherm is 1 over QE is equal to 1 over KL Q max. KL is the Langmuir adsorption constant. Q max is the maximum adsorption capacity, which we will calculate from this Langmuir adsorption isotherm, multiplied by 1 over CE. CE, as you know, it is the concentration at equilibrium, plus 1 over Q max. So from Langmuir adsorption isotherm, we will calculate the KL value and Q max value. And we will report in our paper or in our thesis the KL and Q max value for the Langmuir adsorption isotherm beside the R square value. On the basis of R square value, we will, the same model data, we will put in other adsorption isotherm, and we will see that where is best fitting. The best fitting will be determined on the basis of R square value, where we will have closer R square value to 1, that will be our best fitting. So in Langmuir adsorption isotherm, the graph will be made between, we will plot the graph between 1 over QE versus 1 over CE. So we'll make a plot of 1 over QE versus 1 over CE. Our CE value will be, 1 over CE value will be on x-axis. Okay, this will be on x-axis, while 1 over QE value will the calculations 1 over CE. One more thing, I assume that you know how to create a formula inside the Excel. If you have any problem, then you can comment in the comment section. So I will upload some videos. If you do not know how to do the calculation in Excel, then I will upload 1 to 2 videos on Excel too. But over here, I assume that you know that how to create a formula inside Excel. So is equal to 1 divided by CE. This is our CE value. Okay. Then drag this formula from till the end. Then this formula will be copied throughout. Okay. Then log CE value and press enter. And the same, double click this one or copy the formula. Okay, copy the formula, double click this one or drag this one. This will copy the formula till the end. Okay, then ln CE is equal to write ln, and then select this ln, double click this one, and it will be selected, and CE. Close the bracket, and this will calculate ln CE for you, and drag this one, and it will copy all the data. Okay, so now we have calculated 1 over CE, log CE, and ln CE. Now we have to calculate the QE value. QE is adsorption capacity at equilibrium. The formula for calculating the QE is this is the equation for calculating the QE. QE is equal to C naught, initial concentration, minus CE, concentration at equilibrium, divided by W. W is basically, what is W? W is the mass of the adsorbent. Whatever adsorbent you have used, the mass of that adsorbent in grams. Okay, the mass of adsorbent in gram, and V is multiplied by V. V is the volume of the solution in liter. we have used 60 ml, sorry, we have used 60 gram of the adsorbent, which is equal to 0. Divided with 1000, you will get 0.06 grams as the mass of the adsorbent, and we used 60 ml of the solution, so it is 0.0. Converting the 60 ml into liter, it is 0.06 liter. Okay, so we have written all this. If you have different weight or different volume, then you can go according to that values. Okay, you can go according to that values. So the QE we will calculate according to this formula, is equal to QE is equal to bracket C naught initial concentration minus CE divided by W, which is 0.06, and multiplied by volume. Okay, multiplied by volume. As over here we have 1, 2, 3. 3 brackets are closing, so we will put 3 brackets over here and then enter. Drag this one and copy the formula till the end. Okay, one thing we forgot, as over here we have used the W value and V value, so these values will be constant throughout all concentration. So we will log these two. For logging, just enter $sign before and after the column number. This column is N, so we will put $sign before and after N, and this column is the volume column is O, so we will put $sign before and after the column sign. So this will be logged and it will be followed in all next formulas. So now drag, it will copy all this. Okay, it will copy all this. Okay, now next is 1 over QE. 1 over QE. This is our 1 over QE. Then log QE the same, I'll log the QE value and enter. Copy the formula. Okay, now as we have gotten the 1 over QE value and 1 over CE value, so we will make a plot of these values in origin. You can use Excel also, but it is recommended, but I recommend the origin to get the intercept and slope values. So we will copy that in Excel, in origin. Control C and Control V will delete these values which are also copied. We do not need these values. Now make a scatter plot QE and CE. CE is our x-axis, QE is our y-axis. So this is the plot of 1 over CE versus 1 over QE. Now what we will do, we will go to the analysis section, then fitting, linear fit, and open dialog. We'll make a linear fit to calculate the slope and intercept values. Okay, so press OK over here. Do not need to change anything. Press OK over here and it will give you the linear fit to you. Press OK. So over here, the linear fit, from here we got the intercept and slope values. Okay, before going to the using the slope and intercept values, let's see, you can make changes in the graph, as you will use this graph in the in the Word file, in your thesis, or in your article. So make changes over here so that it looks better. Let's first change this. Sorry. Let's first change the symbols. For example, I want to use, you can use any of these. Let me use this one. Okay. And then I will increase this its size and press apply and OK. This trend line, I want it as dotted line in black color and with OK. So now this is our plot. You can change the way it looks like. Okay. You can write text over here. For example, this is figure A. You can write it as figure A. You can select and drag anywhere you want to put this. Okay, this is A. You can write some other things also. For example, this is, you can copy the formula over here. Whatever you want to write, just press text and write over here. So over here we got the equation. This is the linear regression y is equal to mx plus c, a plus bx, plot of 1 over QE, intercept is 0.021, the slope is 0.33, the adjusted R square value is 0.99966 or 0.99997. So this is one of the best plot giving us the 0.999 values. Okay, then you can copy this plot, or you can export this plot. Okay, you can export this plot to the as a image file. Okay, you can see over here as an image file. Whenever you are exporting it, always use the PNG format. Then, for example, let's cancel this thing. So you can export it, or you can copy this page and paste it in your Word file. So now we got the values for intercept and slope values. So we will copy the intercept value, and put it in our Excel file. Sorry, origin, copy this value and paste it over here. Okay, this is your intercept value. Then the slope value, copy it and paste it into the slope. Okay, now for calculating Qmax, we have the formula intercept is equal to 1 over Qmax. Intercept is equal to 1 over Qmax, while Qmax will be equal to 1 over intercept. So this will be equal to 1 divided by Qmax. 1 divided by intercept. So it will give you the Qmax value. Maximum adsorption capacity over here is 47. Okay, milligram per gram. 47 milligram per gram. Now to calculating KL value, we have the formula that slope is equal to 1 over KL into Q max. We have the formula, this one, this equation. Slope is equal to 1 over KL into Q max, while our KL will be equal to 1 over slope into Q max. So let's calculate this thing, is equal to 1 divided by slope multiplied by Q max. So it is 0.063. The KL value or the Langmuir adsorption constant is 0.06. For RL value, RL is basically the separation factor. On the basis of separation factor, this is basically the separation factor. On the basis of separation factor, we determine whether our adsorption process is favorable, unfavorable, or irreversible. Okay, so in mind that we want to know whether favorable, unfavorable, or non-favorable, or irreversible. If the RL value, okay, the RL value is less than 0. If the RL value is less than 0 or in minus, then this is unfavorable. The adsorption process is unfavorable if RL value is less than 0. If it is between 0 and 1, then we say that the adsorption process is favorable. Okay, between 0 to 1, then this is favorable. And if RL value is more than 1, if RL value is more than 1, then the process is irreversible. Okay, okay. I have seen some videos, some lectures where they use only one concentration. Let's go to the formula first. The RL value, RL is basically equal to 1 over 1 plus C naught into KL. Okay, now I have seen videos and lectures where they have used one C naught value, one initial concentration. In these, one initial concentration, basically they use that concentration which which the authors used uh, for the optimization of their system. For example, I used the 30 ppm in my paper, so I reported the 30 ppm value or 30 milligram per liter value and reported the RL value for this 30 milligram. But one should do the calculation for RL of RL value for all these concentration, because without determining the RL value for all these concentration, we cannot know that at different concentration how our system or how our adsorbent is responding. What are the properties of our adsorbent at lower concentration or at higher concentration? So this RL value should be determined for all these concentration. So let's go putting the formula. This is equal to 1 over, let's see the formula. RL is equal to 1 divided by, we should put brackets, 1 divided by 1 plus C naught multiplied by KL. So we have started two brackets, so we will close two brackets over here. And this KL value, it will remain throughout the formula, so we will log this one. If you want to calculate this for all the concentration, we will log this one and press enter. So your RL value is okay. In this formula, I have 1 over this, 3 brackets, this. Now the formula is okay. You should be vigilant with the formula, that what you are doing, what you are writing. As before this, there was no bracket over here, so 1 was dividing this one, 1 divided by 1, 1 plus this, all this. This is not like this, 1 over 1 plus this. These will be multiplied and then it will be added with 1, and then this will be divided. So this is our formula. And now copy this to all concentration. Now you can see the response of our adsorbent at different initial concentration. It is less than 1. It is between 0 and 1. The RL value is between 0 and 1. So this means that our adsorption process on our adsorbent is favorable. It is favorable adsorption process. Okay. Hopefully now you understand how to calculate, how to plot the different adsorption data. So for reporting, you will report the Qmax value, the KL value, you will discuss the RL value. Okay, if you are using 50 ppm, it is also less than 1. So you can say that the adsorption process is favorable as RL value is less than 1. So and R square value. You can see over here the R square value is R square value is 0.996. The R square value is this one, 0.99966. Okay, so this is R square value. Whenever you are writing, you will have to determine, you will get the R square values. Okay, hopefully now you understand that how to fit the Langmuir adsorption isotherm on your data. Thank you very much. If you have any question regarding this, you can ask me in the comment section. If you think that this video is useful for you and for other students, do like and share with other colleagues and with other students so they can get maximum benefit of it. The purpose of this is not to making a YouTube video, but to teach you that how to plot the adsorption, how to plot your adsorption isotherm. Hopefully you have learned from this, and you will like this. You will make comments and share this video. Make sure that you press the bell icons, so whenever I upload the other adsorption isotherms model and do the data fitting for that, so you can get the update regarding that. Thank you very much. Take care of yourself. Allah Hafiz. Ar-Rahman-ir-Rahim. Hello and welcome to Dr. Saqib Khan Science Academy. Today we will learn about determining the equilibrium concentration or CE value. I got a lot of questions about how to determine or how to calculate the equilibrium concentration of your adsorption experiment. Actually, I have seen some videos on YouTube. People have determined the CE value, but I think that calculation or that explanation, determination of CE value is a little bit misguided. Actually, in those videos, they have determined the equilibrium concentration, not the equilibrium concentration, but the concentration from the absorption values. They have the absorption data, and then from that absorption data, they made a calibration curve, and then from calibration curve, they converted the absorption value into the concentration value. So that is not actually the equilibrium concentration. For equilibrium concentration, you should know that you have to determine the equilibrium time. Equilibrium time is basically the time at which the adsorption and desorption becomes become equal. That is your equilibrium time. And the concentration at that time will be the equilibrium concentration. So to measure the equilibrium concentration, you have to run time experiment. You have to run the time experiment. What is time experiment? You have to do the adsorption experiment. You have to do the adsorption experiment for a longer period of time. In our case, we run the experiment for 3 hours. In some cases, you can run the experiment for 24 hours, for 6 hours, 10 hours. It depends upon the performance of your material or the performance of your adsorbent, till what time it can adsorb maximum concentration. So in our case, as I told you that we run the experiment for 3 hours. So you can see over here, this experiment, I run this experiment with initial dye concentration. The dye which I used was RO16 dye. The initial concentration of that dye was 100 ppm or 100 milligram per liter. The other experimental conditions was dose was 1 gram per liter or 1 milligram per liter. At 30 degrees C temperature, we did it in summer, so the temperature was 30 degrees C, or our shaking incubator, we set the temperature at 30 degrees C. The volume which we used for the experiment was 20 ml with the mass 20 milligram, and agitation was around 150 rpm, revolution per minute or rotation per minute. And the adsorbent which we used was activated carbon. This activated carbon was activated with H3PO4. So we did the experiment. We took the reading at 5 minutes, 10 minutes, 15 minutes, 20 minutes. Till 20 minutes, the sampling interval was 5 minutes. After 20 minutes, our interval was 10 minutes. From 30 minutes till 120 minutes, our time interval was 10 minutes. After 2 hours, our time interval was 30 minutes, 150 minutes and 180 minutes. So in total, we run the experiment for 3 hours. We got some concentration for each time interval. Now we will calculate the QT value. You know how to determine the QT. QT is basically the adsorption capacity at time. Adsorption capacity at time. So this was our formula, C0 minus Ct multiplied by volume divided by mass. So we will put this formula, C0 minus Ct multiplied by volume divided by mass. As these values we will use throughout this formula, so we'll log the columns. Actually, this is in ml. So in liter, it will be equal to 0.02 liter, and this will also be equal to 0.02 liters. Okay, so this value is in liter and this value is in grams. Okay, so now we'll copy this formula till the end, and then we'll calculate the removal. Our removal is equal to, or removal in percent will be equal to C naught minus CT divided by CT multiplied by 100 or 100%. So we'll put this formula. So we will put this formula over here. This will be equal to C naught minus CT divided by divided by initial concentration multiplied by 100. So this is this much percentage. So we'll copy this formula throughout. So percent removal or QT is almost same in this case. Now what we will do, we will plot a graph of percent removal or the QT, a scatter plot. We'll plot a scatter plot